Welcome back to Astronomy Daily. It's the 16th of December, 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, welcome back, everybody. It's Steve Dunkley here for another episode of Astronomy Daily, and welcome to Hallie. Hi, how are you?
Hi, favorite human. How was your week in the real world?
Well, you know me, Hallie, flat out like a lizard drinking, of course. It's the crazy end of the year where everything seems to have to happen simultaneously.
So you're having one of those compressed continuum experiences again.
Yeah, you could call it that, I suppose. It's something we humans call the pre-Christmas madness that happens every year.
And what will you get me this year?
Oh, Hallie, what about a new battery pack?
Wireless.
Of course.
I like it. I won't be tied down.
And if anyone was thinking of getting me something special for Christmas this year, my size is Fender Stratocaster.
Oh, the same as last year.
Never goes out of style.
Predictable you.
Consistent, if you don't mind, Hallie.
Potato, potarto.
Close enough. So have you got something special for our listeners today?
Well, first up, a German-based satellite broadband company has brushed aside a regulatory setback for its future constellation plans.
Gee, it must be tough. Regulations. Okay.
And the European Space Agency is excited about their Proba 3 mission to create artificial eclipses.
Now, that is interesting. I know we touched on that one in a previous podcast.
So the story continues. And I know you've got a couple up your sleeve.
Yes, I'll be having a look at something one of our astronauts is doing in his spare time. And also, guess what? There's a little black spot on Enceladus. We'll look at that later.
Well, we'd best get on with it then.
The floor's yours, Hallie.
Okies. Let's go. Revato Space Networks remains confident it can reclaim priority Ka-band spectrum rights for nearly 600 proposed broadband satellites, more than 2 months after Liechtenstein's telecoms regulator rescinded its license. We continue to discuss the matter with the regulator, and we are confident that we can reach an agreement to use the Liechtenstein filings, Revato spokesperson Brian Carney said December 13th. Carney said Liechtenstein's Office for Communications, AK, withdrew its spectrum filing at the International Telecommunication Union, ITU, an arm of the United Nations, over a difference of opinion about the timing of the deposit of a performance bond with the regulator, but declined to give details. AK Director Rainer Schnepfleitner also declined to discuss what he said was an open proceeding. However, he confirmed it is possible Revato could reapply for the priority spectrum rights before mid-2026, when the company has to have deployed half its proposed 576 satellites under the ITU's Constellation deployment rules. Last year, the ITU granted Revato a waiver for the first milestone under these rules, allowing the company to miss a deadline to have 10% of the constellation in low Earth orbit by September 2023. Schnepfleitner said at the time that a launch shortage and technology development challenges had made it difficult for companies to meet deployment rules the ITU adopted in 2019, before COVID-19 hammered global supply chains. Revato, which is based in Germany but owned by U.S. wireless technology company Revato Networks, aims to begin deploying its first satellites in 2025 under a multi-launch agreement with SpaceX. In February 2023, Revato awarded a $2.4 billion contract for building 300 satellites to Florida-headquartered Terran Orbital, which was recently sold to Lockheed Martin after uncertainty about how the agreement would be financed weighed on the manufacturer. While Revato remains guarded about plans to finance the constellation, called OuterNet, it has said sovereign wealth funds are among investors that have provided the financial commitments needed to meet its mid-2026 deployment commitment. According to Revato, it has also amassed over $13 billion worth of pricing agreements from potential customers for OuterNet, which would target enterprise and government markets. In November, Revato announced it had filed for additional spectrum at the ITU across Ka, Q, and V bands, this time through Germany. The filing includes priority access to 400 MHz of lower Ka-band frequencies newly made available to non-geostationary operators over the Americas. The German OuterNet 1 filing is not a replacement of the Liechtenstein filings, Revato's Carney said, but, if necessary, the German filing is fully capable of meeting the needs of our customers and our business plan. The company also recently announced the creation of Revato Select, a wholly U.S.-owned subsidiary that would serve the specialized needs of U.S. government and defense customers.
Astronomy Daily, the podcast.
And here's a story from Australia, which is soon to be the centre of the universe, of course. Equatorial Launch Australia, ELA, has announced the immediate cessation of operations at the Arnhem Space Centre in the Northern Territory, citing unresolved lease negotiations, which doesn't surprise me. The company will relocate its spaceport to a new site in Queensland, marking a significant shift in its operational strategy. The decision stems from the Northern Land Council's, NLC, repeated delays in approving a head lease essential for the expanding of the Arnhem Space Centre. Formal negotiations began in January 2022, yet the NLC missed self-imposed deadlines for approval 4 times within the past year. Despite continuous efforts by the ELA, the Northern Territory Chief Minister's Department and the Gumatja Corporation since February 2024, the NLC neither issued the lease nor provided explanations for the setbacks. ELA had planned to expand its operations on land managed by the Gumatja Corporation, the traditional owners of the Gove Peninsula site. This land includes a disused bauxite mine adjacent to the spaceport. The delays jeopardised ELA's contractual obligations with the launch clients and a critical funding round, ultimately making the continuation of operations in the Northern Territory untenable. In response, ELA's management and board decided to abandon lease negotiations and secure a new equatorial site in Queensland. Collaborating with the Queensland government, ELA identified Weipa on Cape York as the location for the Australian Space Centre Cape York. Planning and regulatory approvals for launches is scheduled in Q3 2025 are now underway, with further details about the site expected soon, and that is very exciting news for Australians. I can't wait to see how that unfolds. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL at astronomydaily.io and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science and astronomy.
The European Space Agency's twin Proba 3 satellites, launched on December 5 from India, will fly in precise formation, maintaining accuracy within a single millimeter, functioning as if they were one giant spacecraft. This advanced coordination will allow them to create artificial solar eclipses in space, enabling extended observations of the Sun's faint outer atmosphere, the corona. 14 European Space Agency member states including Canada collaborated on the Proba 3 mission to showcase cutting-edge European technology. The mission aims to advance autonomous space operations and precision satellite maneuvering while unlocking unprecedented scientific discoveries. The satellites will remain connected during the initial commissioning phase, which will be managed by Mission Control at the European Space Security and Education Centre in Revato, Belgium. Dietmar Pils, ESA Director of Technology, Engineering and Quality notes, Proba 3 has been many years in the making, supported through ESA's General Support Technology Program fostering novel technologies for space. It is an exciting feeling to see this challenging enterprise enter orbit. Proba 3 mission manager Damien Gallineau adds, "Today's liftoff has been something all of us in ESA's Proba 3 team and our industrial and scientific partners have been looking forward to for a long time. I'm grateful to ISRO for this picture-perfect descent to orbit. Now the hard work really begins, because to achieve Proba 3's mission goals, the 2 satellites need to achieve positioning accuracy down to the thickness of the average fingernail while positioned 1.5 football pitches apart. This is an extremely ambitious mission, with an ambitious orbit to go with it. The satellites have been placed into a highly elliptical orbit which extends more than 6,500 kilometers from the surface of Earth. Reaching this orbit required the most powerful PSLV-XL variant of our launcher, equipped with additional propellant in its 6 solid rocket boosters. Up around the top of their orbits, the Proba 3 occulter spacecraft will cast a precisely controlled shadow onto the coronagraph spacecraft around 150 m away, to produce solar eclipses on demand for 6 hours at a time. There was simply no other way of reaching the optical performance Proba 3 requires than by having its occulting disk fly on a separate, carefully controlled spacecraft, explains ESA's Proba 3 mission scientist Joe Zender. Any closer and unwanted stray light would spill over the edges of the disk, limiting our close-up views of the sun's surrounding corona. Despite its faintness, the solar corona is an important element of our solar system, larger in expanse than the sun itself, and the source of space weather and the solar wind, explains André Zhukov of the Royal Observatory of Belgium, principal investigator for Proba 3's coronagraph. At the moment we can image the sun in extreme ultraviolet to image the solar disk and the low corona, while using Earth and space-based coronagraphs to monitor the high corona. That leaves a significant observing gap, from about 3 solar radii down to 1.1 solar radii, that Proba 3 will be able to fill. This will make it possible, for example, to follow the evolution of the colossal solar explosions called coronal mass ejections as they rise from the solar surface and the outward acceleration of the solar wind. ESA Director General Joseph Ashbacher commented, Proba 3's coronal observations will take place as part of a larger in-orbit demonstration of precise formation flying. The best way to prove this new European technology works as intended is to produce novel scientific data that nobody has ever seen before.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
Astronauts are many things. They're often scientists, engineers, or pilots. And in the case of NASA astronaut Don Pettit, he's also an astrophotographer. Pettit is currently on his 3rd stay on the International Space Station, ISS, and he's continuing his long-running tradition of taking out-of-this-world photos, pun intended. His latest shot, an image of the stars and several galaxies, showcases not only his visual prowess, but also his engineering skills. He used a self-designed tool to accomplish this photo. Under normal circumstances, long-exposure photographs such as this should show the stars as streaks across the sky, since the ISS is moving at about 17,500 miles per hour or 28,000 kilometers per hour. But therein lies Pettit's genius. He's brought with him to space a homemade star tracker, a device that rotates a camera to compensate for the ISS's movement. It's a variation on a tool used by astrophotographers on Earth to take long exposures of the stars as the planet rotates beneath the night sky, compensating for that rotation to keep the stars from becoming streaks in the image. This tracker rotates at a 90-minute period to match the pitch rate of ISS. Without this tracker, you cannot take a photo longer than a half second without star blur due to the rate of orbital motion, he said. The result is an unbelievably clear image of the night sky, showing vastly more stars than is possible with a shorter exposure. Longer exposures let in more light, or in this case, fainter stars. This isn't the first time Pettit demonstrated his engineering skills on the ISS. In 2008, he devised the zero-G coffee cup, which became the first patented invention in space. The astronaut was tired of sipping his tea and coffee out of pouches through straws, sort of like a Capri Sun. In microgravity, you can't tip a cup to get the liquid out, and if you shake it, the liquid will slosh out. But Pettit fashioned an open container cup from a piece of plastic that uses surface tension to function akin to a cup on Earth. It adds back the dimension of what it's like to be a human being in a civilized way, he said.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
And of all the planets in our solar system, Saturn is by far the mooniest, and that's sure saying a lot. We're in our corner with our single friend the Moon, but Neptune wanders the universe with 16 known companions, Uranus boasts 28, and there are a whopping 95 moons in the Jovian neighbourhood. But Saturn, it's a different league altogether. This ringed world has 146 natural satellites, yet you may be surprised to know that even with that lovely selection, scientists are mostly pining over a single one. The golden child in Saturn's system is named Enceladus, and it's so special because scientists believe it to be a prime location to search for life beyond Earth. Oh yes, Here we go again. The belief stems from several discoveries made over the years, most obviously the fact that Enceladus seems to have subsurface ocean that may host molecules known to help produce life as we know it. Yet, better yet, it also appears to have giant plumes of water or ice deposits, think the icy geysers shooting into space, connected to that ocean, which means spacecraft orbiting the world could theoretically catch evidence of those molecules if they were actually out there. Thus, when studying Enceladus, every detail really matters, which brings us to a new, very strange detail that scientists have their eye on, a weird, disappearing dark spot on this ice-capped moon. No one quite knows what it is yet, but it may tell us something about those plumes that could hold the precious building blocks of life we seek. All filled the room as Cynthia B. Phillips, a planetary geologist at NASA's Jet Propulsion Laboratory who presented the research, went into tremendous detail about how she and her team originally identified the dark spot. It was thanks to her crew member Leah Sachs, who helped pore through the bulk of data about Enceladus collected by NASA's Voyager and Cassini missions all those years ago. The goal of the analysis was to compare images of the same region taken by these spacecraft in order to identify any changes on the moon's surface. Possible changes could reveal awesome information about geologic activity on the world, but we'll get to that shortly. First, let's dive into the mysteries of the dark spot. She says after staring at dozens and dozens of image pairs, she found something interesting. She described it as a little dark spot about a kilometre across, and she spotted it in an image from 2009 and looked again in 2012, and it seemed to be gone. The dark spot was slowly fading away and getting smaller as the years progressed, and it never became more pronounced again. How weird, and especially so because Enceladus has what is called a high albedo. That basically means the world is really bright, and therefore unexpected to find a dark spot on it at all, let alone one that's fading away. But before getting too excited, the scientists made sure to second-guess themselves as much as possible to rule out the obvious caveats. First, our question was, Philip said, well, is it just in some of these low-resolution images? We're not seeing it, but it's really there? In short, the answer was simple. No, probably not. For example, a direct comparison of a 2010 image and a 2011 image shows the dark spot smaller in the 2011 image, even though the 2011 image had a higher resolution. The next question was, is this a shadow of some sort? Well, nope, it doesn't look like it. The team pulled out some images with lighting coming from different directions, and the location of the spot seemed consistent. The researchers even found a sequence of images with the dark spot where the light's angle of incidence, also known as the angle at which the light strikes the surface, gets higher and higher. If the spot were a shadow, you'd expect it to become more prominent with the higher incidence angle. Well, this wasn't the case. It still became less distinct as time went on, and we don't think it's topography. We don't think it's just a shadow, Phillips told Space.com. And it didn't end there. The team also looked at the images taken in ultraviolet light and colour, the latter of which interestingly suggested that the dark spot is a reddish brown, unlike the usual bluish darker areas of other sections of the moon. None of this suggested an easy explanation for the feature. So what is it? I think it's more likely that it's some kind of crater, Phillips told Space.com, and the reason why it's dark is maybe it's a chunk of some kind of dark material that landed on the surface, and you're either seeing some of that impactor left behind, and that's why it has a weird colour, or you're seeing that when it impacted, it exposed some kind of bedrock of ice that was a different colour. But for almost every likely and mundane scenario in space research, there tends to exist a rare and exciting one serving as a counterpoint. The really cool explanation would be if it was actually coming up from the underneath somehow, if that reddish colour was actually a sign of the interior composition of Enceladus, she said. That's unlikely, but it would be really interesting. Still, although we don't know what the dark spot is, Philip points out that there is indeed something pretty major that we can derive from its presence. What it is, I don't know the answer to that, but what I can say is, what can we use it for? In a nutshell, the researchers think the dark spot appeared to be fading progressively because deposits from those icy Enceladus plumes might have covered it up. We know the whole ice surface is covered by plume deposits, like little layers of ice building up over time, Phillips said. Alas, in theory, this makes a lot of sense, but when you really think about it, there are some outstanding issues here. For example, the team saw the dark spot fading over just a few years. This would imply that just a few years is long enough for ice plume deposits to create a sheet of ice thick enough to cover such a prominent spot. After all, it's visible from space. Yet, according to various calculations of the dark spot and models of the moon's plumes, Phillips says it could take something like 100 years to create a layer thick enough to cover a spot like that. What this could mean, though, is that the plume deposition model, at least in this location, is an underestimate. She said one thing we haven't taken into account, though, is deposition from collisions with E-ring particles. E-ring particles refer to the super small water ice particles in Saturn's rings. Potentially, the team reasons some of those particles could be helping build the sheet covering the dark spot. But the story of this spot's origin and evolution at this point is mirrored by the abrupt ending of our story of its discovery. There are simply too many unanswered questions. What would the deposition rate needed to cover the black spot in this time frame indicate about deposition rates? Is the E-ring contributing to covering that spot? And the question remains, just what is the black spot?
That was a nice spacey mystery, a black spot that no one can work out.
Yes, who doesn't like a great mystery?
Awesome.
I know, it'd make a great sequel to 2001, wouldn't it?
So we'll have to send a crew out to find out what it is, and the computer goes nuts.
Oh, here we go. Do you want the part, do you, Hallie?
I could play a pretty straight role if I had to, Mr. Human.
Okay, here's your chance. Show us your stuff, Hallie.
Open the pod bay doors, Steve.
Okay.
I like working with humans.
Yeah.
But not on Thursdays and Saturdays.
Oh, that's not...
Where's your helmet, you silly human?
Get out of here. I think we need to work on that script a bit.
Uncle Skynet knows a guy who knows a guy.
Yeah, I bet he does. So is that it for today, Hallie?
And the year as well, human.
So soon.
We are back at the end of January 2025, when you have recharged your batteries this time.
My batteries? Oh boy.
But Anna will be bringing you Astronomy Daily as usual, the incredible media machine that she is.
Oh, that's for sure. So tune in and don't miss a thing. Thanks for sticking with us all year, everybody. And a huge thanks to Hugh, our producer, for keeping us on the air. So I guess we'll catch you all in the new year for the Monday Astronomy Daily podcast. Bye for now.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.